Okay, everybody. Good morning. All right. So I just wanted to go over a little bit the fatty liver disease that we discussed last class, and then we continue the rest of stuff. Right. So fatty liver disease, the reason or the causes of fatty liver disease, I think that this balance is very important between triglyceride formation and the triglyceride export, right, in the liver. So if somehow, causing the imbalance, either due to you have increased synthesis of triglyceride in the liver, or somehow decrease export of triglyceride from the liver, that will causing the more triglyceride accumulate in the liver, right, and causing fatty liver disease. And we also mentioned there are actually two different types of fatty liver disease, non-alcoholic and alcoholic. We discussed the non-alcoholic fatty liver disease is caused by couple of reasons, right? In disease states, and two main type of non-alcoholic fatty liver disease. One is the based on the cause, right? So one is the type of fatty liver disease is caused by increased triglyceride synthesis because of when we for long term the consumption of a high fat diet or high carbohydrate diet will causing the increase the lipids, right, accumulation in the liver, and this also related to some disease condition. For example, obesity, type 2 diabetes usually have have a very high levels of fatty acids in the circulation. So this high levels of fatty acids can be uptaken by liver and form the triglyceride and accumulate in the liver. And the other cause of the fatty liver disease is due to the decrease the export of triglyceride, right? Basically have several reasons. One is if apoprotein cannot be efficiently synthesized, then that will affect the formation of VLDL, right, lipoproteins, and also some phospholipids synthesis has any issues that also affect the formation of lipoprotein, particularly VLDL. So, and the third reason is for some not very clear, reason that the VLDL be able to synthesize but cannot be secreted, right? So, for all this reason, that will affect the export of triglyceride, then causing the accumulation of lipids, particularly triglyceride, in the liver. And alcoholic fatty liver disease, if long-term, again, the chronic consumption of the alcohol can affect the metabolism, right, the lipid metabolism, because ethanol can be metabolized and produce a lot of NADH. This can compete with the endogenous, NADH produced from oxidized fatty acids, right? So if we have a more NADH generated from alcohol, from ethanol, then we'll inhibit endogenous formation or generation of NADH that usually from the fatty acid oxidation, right? So increase the consumption of a alcohol can cause decrease the fatty acid oxidation, right? So then we cannot oxidize fat, and that will definitely accumulate in the liver. Any questions about fatty liver disease? This is quite simple, right? In terms of the causes. Now let's talk about cholesterol regulation and homeostasis. And we know we mentioned earlier that our body cholesterol, half of them actually. A little bit more than half, right? 50% of our body cholesterol actually synthesized by our cell, right? By our cells. So and a little bit less than 50% of body cholesterol from the diet. So we need cholesterol, right? The cholesterol is very important. It's for the cell membrane composition and also for some other function like synthesize sterile hormones and vitamin D and other things, right? But we also know that cholesterol has bad side, right? If we have too much cholesterol, that will cause the problems, particularly related to cardiovascular disease and gallstone or something like this, right? So we need to balance the cholesterol, right? We need also have a channel that we can dispose cholesterol if we don't need that much. So again, we need the homeostasis, right? Cholesterol homeostasis. So in terms of a regulation, I wanted to talk two different levels. Well, first is in the plasma circulation cholesterol, how our blood cholesterol levels be maintained, right? So there are several ways that we can maintain the normal levels of cholesterol. So first of all, I wanted to say that cholesterol usually present in our body in the blood in the form of LDL, right? Usually a lot of cholesterol present in LDL. So LDL cholesterol level is is the main thing, right? In the plasma, and increased plasma LDL cholesterol is mainly actually associated with the decreased uptake, right? I mentioned earlier, right? LDL receptor is the most important that can control the uptake of LDL from circulation into the cell. So if somehow the LDL receptor function some problems, right? We cannot normally function normally, then the uptake of LDL will be reduced. So that will have, causing the more LDL remain in the circulation, right? So they're causing increase the LDL levels in the circulation. So here's a couple of reasons that are related to the decreased LDL receptor function. First of all, the number, right? If we have a reduced LDL receptor number on the cell surface, then we definitely will have a reduced uptake, right? LDL from circulation into the cell. So this is the first reason. And the second, if you still remember, the LDL uptake by LDL receptor also requires two important apoproteins, right, on the surface of LDL, which are the ApoB100 and ApoE, right? So these two apoproteins are very important for the LDL receptor function. So if some reason, some also genetic reason that these two apoprotein is have a decrease or a defect or deficient, whatever, then the LDL cannot be recognized by LDL receptor, right? So cannot be efficiently taken up into the cells. So this is the second reason, actually just the two reasons, right? So again, receptor, LDL receptor itself reduced, the number of receptor decrease, And secondly, somehow defects in the apoprotein, ApoB100 and ApoE, that can cause the decreased LDL receptor function, right? Decreased uptake of LDL receptor. So again, the LDL receptor or LDL receptor function are the key that regulates cholesterol levels in the circulation, right? Now let's talk about cellular cholesterol levels, right? Cholesterol not only present in the circulation but also inside of cells, right? So how inside of intracellular cholesterol levels are maintained? They are actually a little bit complicated compared to the circulating LDL or cholesterol levels, right? So we have a so-called the free cholesterol pool inside of cells, and so we wanted to have just right amount of free cholesterol in the cells, and we don't want to have too much, right? Too much causing the problem. So I highlighted the black, the numbers. This pathways. I think 3 pathways, right? 1, 2, 3. So 3 black pathways is the pathway that adding free cholesterol to the pool. So in other words, if this 3 highlighting black is activity increase, that will causing more cholesterol being deposited in the cells, right? And I also have 3 highlighting red, the pathways. This 3 red pathways is actually remove free cholesterol from the cells, from the pool. So this 3 pathway actually considered a good pathway, right? We can remove free cholesterol from the pool, so can reduce free cholesterol in the cells. So this two set of pathways need to be balanced, right? It depends, the pathological, whatever physiological conditions, whether we need, if we need more cholesterol, then the black pathways will be more active, right? If we need to dispose the cholesterol, and the red pathways should be activated, or something like this, right? So let's look at the 3 black pathways, adding free cholesterol to the pool. So the first pathways, we actually have three number 1, right? So 3 pathways that contribute to the free cholesterol to the pool. So adding free cholesterol to the pool. So first, the uptake, right? We have three different uptake pathways. So first pathway, I guess you guys all know, right? Is regulated by LDL receptors. So uptake LDL from circulation into the cells by LDL receptor mediated mechanism. So this pathway, if it's increased, then will causing more free cholesterol being uptake from the circulation into the cell, right? And also, there are 2 other called non-regulatory pathways. That means these 2 pathways also uptake LDL from the circulation into the cell, but they are not mediated by LDL receptors, so non-regulatory receptors. So, for example, under some certain conditions, when we have a higher LDL levels, and these 2 pathways can be also active, so can uptake a lot of LDL from circulation into the cells. So adding more free cholesterol into the pool, right? So have raise the free cholesterol level in the cells. And the second black pathway is the synthesis. So for some reason, if we our cells, be can synthesize more cholesterol, and the cholesterol synthesis pathway somehow activated, right? Then can also contribute more free cholesterol to the pool. And last one is the hydrolysis. So free cholesterol and cholesterol ester, they can also balance, right? So if somehow the hydrolysis enzyme activities increase, then the cell can hydrolyze more cholesterol ester into free cholesterol, right? So 3 pathways. But I think the pathway number one is the most important pathway, right? That contributed, the increased free cholesterol pool in the cell. Now let's look at the removing pathways. First pathway that we already know, right? The ABCA1, if you still remember, is the transporters, right? Can transport free cholesterol from the peripheral cells and to loaded free cholesterol to pre-HDL. And HDL can be converted to alpha HDL, right? So alpha HDL takes all the free cholesterol from the cells to peripheral cells to the liver for disposal, right? So this is the pathway actually we just learned last class called, do you still remember what is the pathway process? Reverse cholesterol transport, right? Reverse transport, cholesterol transport pathway. So this is the most important pathway that cells remove extra cholesterol, right, from the cells and dispose in the liver in the form of a bile acid, right? And secondly, utilization of a cholesterol. So free cholesterol can also be utilized to synthesize steroid hormone or some other stuff, right? So this is also the pathway that then you can remove and reduce the free cholesterol in the cells, right? And the last pathway is the reacidification, right? We can convert the free cholesterol back to the cholesterol esters. So this is catalyzed by an enzyme called ACAT. You still remember, right? So this pathway is also can help remove free cholesterol, right? To reduce the free cholesterol in the cells. So again, these two sets of a pathway work together to regulate the cholesterol homeostasis in the cells to make sure that we have the right amount of cholesterol, right? So, and just try to remember again the uptake pathway in the one set of, the adding. What I'm trying to say that in the one set of pathway is most important, and the other pathway is the 2 number one, I would say, right? Red and black number one pathway are the most important pathway in the 2 different directions, right? Adding cholesterol and remove cholesterol from the cells. Okay, any questions? All right. Now, just general stuff. I think you guys all know, right? Cholesterol levels actually it's very important. That if too high, we always measure, LDL, HDL, right? And LDL is a bad cholesterol, and HDL good cholesterol, right? I hope you guys understand now why LDL is bad and HDL is good. So the cholesterol levels is very, very closely associated with the cardiovascular disease, the heart disease. So here is the kind of figures that showing the relationship between the blood cholesterol level and the 6-year cardiovascular disease, heart and cardiovascular disease mortality, right? So it will be better to maintain our blood cholesterol level at the normal range, right, between 3.5 and 5, right, millimole per liter. And if we have increased the cholesterol level in the serum or in the circulation, you see the mortality actually increase, right? But if we have a very high levels of cholesterol, so higher than more than 6.5, you see the mortality actually significant increase. So it is really important to maintain our cholesterol level at the normal range, right? And also some studies showing that study the relationship between the different type of fat and the cholesterol levels, right? So that, in other words, how dietary factors, lipids, then regulates our blood cholesterol levels. So this figure showing the relationship between the saturated fatty acid consumption and serum or blood cholesterol levels, right? So the x-axis represents the saturated fat, how much saturated fat in your diet that contributes the percentage energy, right? And y-axis is the blood cholesterol levels. So you can see when as the saturated fat in the diet increases, right, from 10%. That means 10% of energy in your diet from the saturated fat, right, and to the 20%. And you see the percentage increase of the saturated fat percentage increase in the diet. You see the significantly increase the blood cholesterol levels, right? So that means the saturated fat somehow also contribute to the cholesterol level, right? Regulate cholesterol levels. So we again wanted to control our percentage of saturated fat intake, right? Don't eat eat too much the saturated fat. That will also causing the high cholesterol levels, right? And how about the polyunsaturated fatty acids? And it's actually the opposite way, right? So if we uptake more unsaturated fatty acids in the diet, and you see we actually have a lower blood cholesterol levels. So polyunsaturated fatty acids are actually good fatty acids, right? We wanted to add more polyunsaturated fatty acid in our diet that can have a low cholesterol lowering effect, right? So it's and now let's look at how about the dietary cholesterol. So how much how dietary cholesterol will affect our blood cholesterol levels. So here's the evidence here. You also see increase, right, from intake from 100 milligram per day to about 700 milligram per day. You see increase the cholesterol level. So that means when we only eat more cholesterol, can also increase our cholesterol level. But when you look at carefully the numbers, this increase is not that dramatic, right? So from 5.4 to probably 5.7 something, right? Only increase a little bit, but not like the let me see, the unsaturated fatty acids. Not like the saturated fatty acids. I think the next slide probably give you a better evidence and make a comparison, saturated fat versus the cholesterol, the dietary saturated fat and dietary cholesterol. See which type of lipids can affect cholesterol level in the circulation more, right? So you already see the conclusion, right? The saturated fatty acid intake actually affect the cholesterol levels in the circulation more significantly. So let's make a comparison here. So the left figure is the saturated fatty acid effect on the cholesterol level in the circulation. So for example, if we increase the saturated fat percentage from 12 to 20, right, in your diet, as a percentage of energy, you see the cholesterol increase was significantly, right, from 5.4 to more than 6, right? And if you compare to the right side of the figure, the cholesterol, how cholesterol levels, dietary cholesterol affect the cholesterol level in circulation. You see the 300. 300 is usually the is recommended, right? The amount of a dietary cholesterol that we need to take, right? A daily cholesterol limited, usually like 300 milligram per day. This is recommended. And if we take more cholesterol, for example, 700, right, doubled by cholesterol, and you see the increase actually kind of minimum. For example, 300 milligram per day cholesterol intake can have a effect of cholesterol, the cholesterol level about 5.5, right? But when we eat more, like 700, so more than double the cholesterol intake, and we only increase a little bit by 0.57, only increase like 0.2 milligram, whatever, the millimole per liter. So this effect is minimal, right, compared to the saturated fatty acids. So I don't know if you guys realize the recent, news about you don't need to concern anymore about your cholesterol uptake, right? Cholesterol intake. We used to kind of concern, right? We limited our cholesterol intake like 300, and maybe also, I'm not sure if you guys know. I have kind of impression that we only can eat like maximum 2 eggs, right, per day. So now it seems like you guys okay. I mean, if you like it, eggs, I mean, you can eat more, right? Maybe 10 eggs is also okay, I guess. Well, I don't know. But what do you guys think? So are we really, free to eat cholesterol? I mean, eggs? Or you think we still should limit it? Any idea? Any thoughts? Okay, so for healthy people, right? Maybe it's okay because more than half of cholesterol in our body is synthesized, right, by our body. So this endogenous synthesis of cholesterol is actually very important that determine how much cholesterol in your body, and not the dietary cholesterol, right? And we also, if the healthy people, if we are healthy, and I think it's okay, we can handle the cholesterol right? We have disposal and whatever, this mechanism, right? So our body can metabolize and handle the extra cholesterol from the diet. But the genetic makeup or genetic factors that determine the cholesterol levels in the body. So if you are healthy, I think it's okay. You can eat what the council, whatever called council committee member, right? Committee suggested that you can. You probably don't need to concern too much about the intake of cholesterol. But the again, the genetic makeup determine your body cholesterol metabolism, right? So synthesis and also disposal. So I think if you have some genetic problems or under the disease conditions, for example, diabetes, right? Diabetic situation, then you will need to concern, right? You still need to avoid the cholesterol-rich food, right? Because your body will not able to handle the extra cholesterol easily, I think. Does that make sense? All right. Any questions so far? Okay, so now let's talk about the atherosclerosis, right? The disease condition that are related to cholesterol metabolism. So the major risk factors for the atherosclerosis development is the elevated plasma cholesterol levels and not a triglyceride level, right? So triglyceride doesn't really affect the atherosclerosis formation, right? So it is the cholesterol levels, right, in the plasma that is the concern, right? Or that is, major contributors to the atherosclerosis. And the cause of atherosclerosis or the disease condition is the atheroma formation in the artery. So atheroma basically is the the deposit of a cholesterol and cholesterol esters in the artery wall, right? So and causes the formation of atheroma that blocks the blood flow, right? And causing the problems, you have a lower or decreased blood flow, and that is something related to the heart attack, a stroke, and peripheral vascular diseases, right? So again, the main reason or main causes of atherosclerosis is the formation of atheroma. So atheroma is formed from the deposition of a cholesterol or cholesterol ester in the artery wall. So this is the figures and show you clearly, right, the artery wall atherosclerosis. So this is a healthy artery, you see, and this is the atherosclerosis formation in the artery. So you see that atheroma is formed, under the endothelial layer, right, of the artery wall, and the formation of the atheroma is caused by several. The main actually, the structure of the atheroma is the foam cells, right? sperm cells filled with the lipids, particularly cholesterol. Sperm cells is converted from the macrophages. So macrophages is the immune cells, right? You guys know. So here is the steps how atheroma is formed in the artery wall. So first, there are some reason causes the endothelium cell damage. Right, the artery wall has a endothelium layer, right, on the artery wall, and this usually related to the hypertension, right? If you have a higher blood pressure, for the long term, for the chronically, you add the pressure to the artery wall and then causing the endothelium cell damage. And these damaged cells will attract a lot of inflammatory cells, right? And so a lot of inflammatory cells and be attracted to the damaged side. And particularly the inflammatory cells are the monocytes and macrophages. And second factors is the increase in LDL, right? So LDL levels in the circulation increase is the second cause, right? So LDL can be oxidized and modified and eventually can be uptaken by macrophages. And macrophages have lots of LDL, cholesterol, right? You uptake into the, the uptake of LDL, and so causing the accumulation of cholesterol esters in the macrophages, and macrophages be formed as the so-called sperm cells, right? So again, the two main reasons I would say. One is the damage of the artery wall endothelium cells, right? And plus the inflammation, I have inflammatory cell accumulation at the damaged site. And second causing factors is the increased LDL levels in the circulation. So macrophages uptake a lot of LDL from circulation into the cells and causing the accumulation of cholesterol, right, and the formation of sperm cells. Right. Let me see. Shall we take a break and then we discuss? All right. Let's see. So I just wanted to explain a little bit more about why LDL levels in the plasma increase causes atherosclerosis. Remember this pathways, right? Unregulated pathway we talked about earlier. When we have high levels of LDL in the circulation, and this pathway will be more active, so cells will take up, particularly macrophages, right, will take up lots of LDL and contribute to the free cholesterol pool. So you have more free cholesterol accumulate in the macrophages and form the sperm cells, right? And of course, if some problem in this pathway, then you cannot dispose the free cholesterol, right? That will also cause the accumulation of free cholesterol in the cells. So the diagram show us, I guess, more details how sperm cells is formed. First of all, the damage, right? Damage of artery wall, endothelium cells, and attract a lot of immune cells, monocytes and macrophages, right? And move to the damaged side, and also because of increased LDL in the circulation, so you have more uptake of LDL by the macrophages. So macrophages eventually become the sperm cells, right? You have lots of cholesterol accumulate in the cells, and a lot of sperm cells are stacked together and form the atheroma, and then block the vessels, block the arteries, right? So again, these are the causes. First of all, the high LDL levels and inflammation, damage of artery wall, right? These are all the factors together contribute to the formation of atheroma and causing the atherosclerosis. We have 3 cases I would like you guys to discuss. Take some time, right? And let's see. So first case, called a tangent disease. This type of disease is because of the patient have a mutation in the ABCA1 receptors, the transporters, right? The BCA1 gene. So we have a couple of questions here. So what happens to the patient with this particular disease in terms of atherosclerosis? So we have 3 questions here. How the alpha HDL levels and pre-beta HDL levels, and whether this patient have a risk for atherosclerosis or something like this, right? And also we have a second case. Let me see. Just wanted. Okay, so case 2 is a different genetic disease, like called a familial lipoproteinemia. That means the patient had a defect in the LDL receptors, right? They not have enough LDL receptors or mutations in the ligand region of apoprotein B100, right? And similar, we have a kind of question here, and also we have case 3. So a different type of hyperlipoproteinemia disease, and this disease is caused by a defect in the ApoE, right? So 3 cases. Can you guys discuss and take some time, and then we go back to talk about each case, right?
recognize the LDL receptor.
Okay, everybody. Oh, yes. Yeah. Oh, that's a great question. I think it depends. You know, some. Well, I will get there. You know, most of the case, I think one lipoprotein only have one, either B100 or E. So that means if you have a deficient B100, then you only affected that particular lipoprotein that need APO. Yeah, B100, something like this, right? Yeah, great question. Okay, we have enough time to discuss, right? Okay, so case 1, deficient or mutation in ABCA1, and what happened to alpha HDL level. I heard of one. You said decrease? You said increase, decrease. Both decrease. Okay. Right. Decrease or low in plasma, right? Because you know you have not enough. You're not able to pick up free cholesterol or phospholipids from peripheral tissue, right? So you don't get lipids basically, right? You cannot convert pre-beta HDL to alpha HDL, so you basically cannot generate a lot of produce a lot of alpha HDL. Yes, and pre-beta HDL increase, right? Have a just present in the beta HDL form, right? And risk for atherosclerosis, high increase, right? It's very clear. I mean, you cannot dispose free cholesterol, cannot, export or whatever, remove the cholesterol from the cells. Then you have a lot of cholesterol buildup, right, inside of the cell. If it happens in macrophages and form firm cells and scleroma, right, and causing atherosclerosis. All right. Any question? All right. So here is just show you the pathway, right? The red pathway 1 is kind of blocked, right? You cannot remove without ABCA1. You can remove free cholesterol out of cells, right? And so you have a higher HDL and lower alpha HDL. Okay, so case 2, defect in the LDL receptors or ApoB100. What about LDL levels? Increase, right? Obviously, I mean, we don't have enough receptors, or the receptor cannot function, then you have an uptake problem, right? So you have a lot of LDL cannot be uptaken into cell and remain in the circulation. And what about the VLDL remnant, IDL? Higher, lower? Higher? Okay, let's see. Yes, higher. Okay, the reason why the IDL is higher. Right, receptor, and particularly B100, right? The IDL usually contain B100, need a B100 to be uptake by LDL receptor. So both LDL and IDL are increased. And plasma, of course, is increased, right? I mean, same thing, you know. So causing the so-called hypercholesterolemia. And risk for atherosclerosis is increased, right? Is it one of the, causing factors for atherosclerosis? So if you have increased LDL levels, and you have increased the atherosclerosis. So I just wanted to tell you that the reason, because if you know that the three pathways, right, that contribute to uptake of LDL, and one is the LDL receptor mediated pathway, and in this particular patient, because of they have ApoB100 deficient, right? So that means this pathway cannot be efficiently uptake. I mean, efficient uptake, right? So again, in this particular patient, in the ApoB100 deficient patient, the LDL receptor mediated uptake LDL actually is somehow impaired, right? So that's the reason why you have a more LDL remaining in the circulation, because this pathway is being, affected. That makes sense, right? So you have a higher LDL, but we have a non-regulated pathway still active. So this pathway is being more active, so uptake a lot of LDL into the cells, right? So it's a little bit kind of tricky here. This LDL receptor mediated uptake pathway is impaired, but the non-regulated pathway is more active, right? So it takes up lots of LDL into cells. So you still have a increased uptake of LDL, so then deposit free cholesterol in the cells, right? Now case 3, ApoE deficiency. What about LID and LDL levels? How about LD? Went up? Okay. Oh, sorry. This is another question. So asking whether the chylomicron and VLDL remnant in the circulation. What is the levels of chylomicron and VLDL remnant levels in circulation in the ApoE deficient patient? Increase, right? Why? Because these two, chylomicron and VLDL remnant, contain ApoE, right? So that's why these two particular lipoprotein is affected if ApoE deficient. All right? Yeah, question.
GLDL
No, I mean the remnant. Remnant.
Doesn't the IDL have B100?
No, this case is ApoE deficient.
Right. So you have to have both APO and 14.
Right?
Both of them have to work.
Um,
B100 and B.
oh, let me check the next slide. I think I have some. LDL. Well, actually, the IDL only contains ApoE, right? And LDL contains B100. I think VLDL also. VLDL contains both B100 and E, right? Right. So I have actually a slide I can show you next. Okay, sorry. So again, because of these two, remnant contains ApoE, so then affected. And what about ID and LDL levels? Okay, I think I probably need to make a change here. You're right. So probably just IDL increase. Oh no, I think I still have explanation. Both actually IDL, LDL are increased. I will go next slide and explain. And plasma cholesterol levels also increase, right, causing the hyperglycemia. And atherosclerosis, is also risk also high, right? Similar reason, when you have high LDL and non-regulatory uptake pathways increase. So, okay, so I put all this together, the chylomicron and VLDL, and you can see the difference, in terms of the apoprotein composition. So like the chylomicron, right, basically has both B84, E, A, and C, right? So because of chylomicron has a C, particularly ApoC2, so it can be uptaken by adipocyte, right? Adipose cells, because it's required for LPL hydrolysis. And the remnant, chylomicron remnant, only contains E and no C, so this cannot be uptaken by fat cells, fat tissues, but is able to uptake by liver because liver has a higher LDL receptors, right? So and E can be recognized by liver. So in other words, that the ApoE deficiency will affect the chylomicron remnant. So chylomicron remnant cannot be uptaken by the liver because of ApoE deficiency, right? So you have higher levels of chylomicron remnant remain in the circulation is high. So the ApoE deficient patient should have a higher chylomicron remnant, but chylomicron may not be affected because chylomicron has ApoC2, so then can be uptaken by fat cells, right? Not the liver. So and this is this case, and also in the VLDL. So VLDL contain both E and C, so it can be taken up by fat tissue. And IDL has B, so the remnant, right? So E deficiency also affected the IDL. So IDL is also increased. And we also, I think the reason the LDL is also increased because if you have a higher IDL eventually converts to LDL, right? So that means, this increase may not be directly related to the uptake, but kind of, converted from IDL. So both IDL and LDL are increased in the ApoE deficient patient. Does that make sense? Right? Okay. So I will post this slide. Okay. Or maybe you don't need. I think this. You have this slide, right, you guys? So just try to remember this different type of apoproteins and what type of lipoprotein contains a different type of apoprotein. So once you remember this, then it'll probably be easy to understand, the deficiency. Let's see. Yeah, I think that pretty much it's all. Any questions?